of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. So here's what that says. That's a really fancy way. Here is the more realistic way. It says if you have an isosceles triangle, right, the two sides that are the same are these two sides with our tick marks. And like we said when we warmed up, those are called our legs. So if I have a segment that goes straight through the vertex angle, and so remember the vertex angle is the angle that's the one that's different than the base angles, right? So my vertex angle in this picture is angle B. So I'm going to highlight the word vertex angle. I'm going to highlight my angle B right here. That's my vertex angle. So if you have a segment that bisects that angle, then what that means is on both sides, these two angles, like the angle B that's being cut in half, these two are exactly the same up at the top. So like if this angle over here is 50 degrees, then that means this angle over here also has to be 50 degrees. They have to be the same thing, right? So I'll put 50 degrees, 50 degrees. Those two have to be the same, bless you. What that also means is it will cut this line in half, meaning that this is your base down here, right? So this was your isosceles triangle. This is the base down here below. That's the base. And essentially what you're doing is taking that base and you're cutting it in half. So now these two pieces of the base should be exactly the same. So let's say I told you that the whole base was 10 inches. If I bisect it, cut it in half, what does that mean the two pieces have to be? 5 and 5, right? They have to be two pieces that are the same. So this piece would be 5. This piece would be 5. So essentially what happens is when you have this bisector that cuts straight through the isosceles triangle, essentially you're making two smaller triangles that are exactly the same, right? Essentially they're just being reflected over onto the other side. It's the exact same triangle, just like smaller versions, okay? And then of course, you've got this box right here. What does this box stand for? 90 degrees. So when you cut directly in half, not only are you making two smaller triangles that are the same, you're also making 90-degree angles down at the bottom as well. So that's important. So now we're going to use that information and we're going to solve for our problem over here. So let's take a look at number 1. First and foremost, this is an isosceles triangle. Which two sides are the legs? Those are just points. I want to know the legs. Which two sides? PS and RS. Yep. So the two sides here that have these tick marks, these are our legs. Legs. So those two pieces should be exactly the same. What's that piece called all the way at the top there by itself? The base. Good. And so don't let it freak you out that it's upside down, but this purple piece here is your base. Okay, so it says QS bisects the vertex angle. Which angle there is the vertex angle? Which angle is being cut in half? Angle S. Very good. So my vertex angle is this angle right here, angle S. Okay, so my first question says, what is the measure of angle RSQ? RSQ. So I want to know what is this little angle right here all by itself. Okay, so we're going to add in everything that we know. Because this is perpendicular and it's bisecting, it makes 90-degree angles. So I'm going to go ahead and I'm going to draw in my 90-degree angles. And it's the same on both sides. So you really have two 90-degree angles. Now, there's another angle you know for sure in this picture. What's the other angle that you know for sure? 31 right here is angle P. What other angle do you know for sure? R. What's angle R? It's 31 as well. Good. So I'm going to put my little two arc marks here. I'm going to write 31. Good. So now you've got your two 31s. I still, though, need to figure out what one of those angles is at the top, right up here. I want to know what one of the measures is of this angle. Now, Lexi told us at the beginning of class, what did you tell us, Lexi, about isosceles triangles? All three angles good add up to be 180. So look at this. There are two small triangles within the larger isosceles triangle. If you focus just on one triangle, so I'm going to focus just on the right triangle. It doesn't matter which one you focus on. But in this triangle, you already have two of the three angles. What are the two angles that you have? 90 and 31. How do I figure out the last angle that's left over? Good. Add those two together, subtract them from 180, and that's going to give me what's left over in the triangle. So that's what we're going to do. And I think, hopefully you remember, we wrote it like this. We write 180 minus parentheses 90 plus 31. So we're adding those two pieces together, and then we're taking them away from 180. Okay, what is 90 and 31? 121. And what's 180 minus 121? Is what? 59 what? Degrees. We're talking about an angle. Good, 59 degrees. And that's it. So this little angle right here that's got one arc mark, this is 59 degrees. What does that mean this angle right next to it is as well? 59 degrees. So essentially it's the same triangle, just flipped. It's almost been reflected, right? You've got two triangles that have just been flipped over. And that's it. You figured out your answer. 59 degrees. Easy peasy, right? Okay, next question says, what is PR? PR. So now we're talking this time about a side length, right? This is a side. This is the base. Talking about a side length this time. Now, you already know one piece of that length. You know one piece is QR right here, and QR is 4. What do you think that means this one over here has to be? It's exactly the same thing. Yeah, it's just being reflected over onto the other side. So since 1/2 of it is 4, the other half also has to be 4. And we're going to mark that they're the same by putting tick marks. But when we put our tick marks, we want to make sure we put 2 because we've already used up the 1 tick marks over here for the legs. So I'm going to put 2 tick marks, 2 tick marks. So if I want to know the full length of PR, what's the whole length? 8. How'd you get 8? Yeah, add the 2 together. Good. 4 plus 4. So your whole length is 8. 8 units, or just 8. And there you go. You figured it out. Beautiful. Next bad, right? So isosceles triangles that are bisected means you're taking it and you're cutting it in half. So since you're cutting it in half, you're making 2 smaller triangles that are exactly the same. So whatever you see on one side, automatically you should just mark on the other side as well. Okay, what questions can I answer so far? None yet? I'm that great? Okay, wonderful. Let's take a look at number 2. All right, so it says AD bisects the vertex angle. So here's AD right in the center. It is cutting my triangle in half. So there are definitely some things before we even look at the questions. There are some things that we can mark in our picture, right? So things that are not marked for me right now, but that I can mark in. Who can give me something that we can definitely mark in this picture? Chelsea, what do you think? The 2 legs, good. Which ones are the legs? Great. Leg and a leg, gorgeous. Legs, there's 2 of them. Okay, what else can I mark in my picture? What? On which part? Say it louder. On angle B and C, and so what should angle C be? Yeah, it should be 67 degrees, right? Because whatever happens over here, I flip and it happens over here. So this one is also 67 degrees, and I'm going to put 1 arc mark because we don't have any arc marks just yet. Good. What else can I mark in that picture? Angel? The other 90 degrees on the other side. Good. Okay, and there's one more thing I can mark in this picture.
24?
Well, I don't need to mark 24 because it's already, well, I guess I could technically, but yeah, it's marked kind of for me already. The 24 is the same on both sides. There's one more thing that we can mark. Lexi?
The base is for B is 10.
Yeah, good. So this half of the base from D to C is 10. That means this half of the base over here from B to D is also 10. Good. All right, so now that we have everything marked in our picture, now we'll go and take a look at the questions. So first question says, what is the measure of angle DAC? DAC. So that means I want to know what this small little piece right here is. DAC. How am I going to figure out that angle? Chelsea, what do you think? Beautiful. So if we focus just on this bottom triangle here, just like what we did the first time around, we know that you already have a 90 and a 67. So we got to take those, add them, and subtract them from 180, and that will give me what is left over. So let's do that. 180 minus 67 plus 90. So hopefully you're noticing we're kind of doing the same thing over and over and over again. All right, who can do that math for me? Tell me what you got. Chelsea, what'd you get? 23 degrees in total. Very nice. So that little tiny angle right there, DAC, is 23 degrees. What else can we mark in this picture? Good. The other side should also be 23 degrees. So notice it's like the same thing on both sides. Once you got one side, the other side should be easy peasy, you call it. Okay, next part. What is BC? BC. How'd you get 20, Eddie? Yeah, good. Added the two pieces together. So here's B to C. So we add together the two 10s. Easy peasy. Okay, last part. What is AC? Now, hold on a second. AC, is that a side length or is that an angle? That's a side length, so I don't want to put an angle marking for it. 90 is an angle. This is a side length right here from A to C. That's a side. Side length. So here's what I'm going to do. I'm going to focus just on the smaller triangle that has the AC in it. So I'm going to ignore the triangle on the top, and I'm just going to look at this bottom triangle right here and nothing else. Now, if you take a look at that triangle at the bottom, that blue triangle there that I just highlighted, it has a 90-degree angle in it, so it's a right triangle. You've got two of the side lengths already. What are the two side lengths you already have in that blue triangle? The 10 and the 24. Good. I need to figure out, though, the third side. And there is a theorem you already know. I know you know it because you learned it in probably 8th grade. That helps you find side lengths of a right triangle. Can anybody remember what it is? A very famous man wrote a very famous theorem. His name was Pythagoras.
I cannot physically say the name, but I know what you're talking about.
Pythagorean Theorem. Does anybody remember what it is? Woo! Yes! Give yourself a pat on the back. A squared plus B squared equals C squared. This only works for right triangles and nothing else. And this is one you got to know because it's Miss Damasso's favorite theorem. So it's an important thing that you know it because it's my favorite. Okay. Good to know. Might be a test question. What's Miss Damasso's favorite theorem? Pythagorean. Okay. What this says is you can plug in the legs of the triangle to the A and the B. And this part C is the longest side of the triangle. It's called, does anybody know what it's called? It starts with an H. Oh my gosh! Hypotenuse. The longest side of the triangle. So that hypotenuse is the side that is always across from the 90 degrees. So if we're looking at our blue triangle here, here's my 90 degrees. If I go directly across from it, are you given this side length over here? Do you know what it is? No, that's what you're trying to figure out. So what we're going to plug in is the a squared and the b squared, and that's the other two sides of the triangle. And so what are the two sides of the triangle that are left? You said it before. The two side lengths of that triangle are which two sides? Yeah, the 10 and the 24. So we're going to plug in a 10 and a 24 to the A and to the B. It does not matter which one you plug in where. I'm going to plug in the 10 first. So 10 squared plus 24 squared equals C squared. We're trying to figure out what that last side is. And so my apologies, you're going to have to write kind of tiny. Okay. Does everybody know where the squared button is on their calculator? Yeah, no, maybe so. So here's what you do, right? Okay, so again, you definitely need to know how to do it on this calculator because this is the calculator you're going to use, unless you have your own, this is the calculator you're going to use on your midterm and your final. So if you want to put in 10 squared into your calculator, that means 10 times 10, which is what? 100. But here's how you put it into your calculator. Put the 10 first. And everybody should have, regardless of which calculator you're using, there should be a little squared button. So on this black calculator, it's the third one on the top there. See that little X squared button? You just click it. And that'll square the number for you. So again, you just put the number in that you want to square, the number 10, and then I just push this X to the 2 button right here. Boom, and you get 100. So your first number is 100. Plus, now you have to do the same thing for the 24. So again, put in the 24, and then push the X squared button. What number do you get? 576. Good. Did anybody not get that on their calculator? It's okay if you didn't, just tell me. All right, good. 576. And I'm running out of room. All right, very small now. Okay. Next thing we're going to do is we're going to add those two numbers together. What is 100 plus 576? 676. There you go. 676 is my C squared value. But now I need to undo the squared because I don't have the C all by itself. And the opposite of squaring something is square rooting it. Oh my gosh, you guys are so smart. Okay, so now this one you definitely need to also know how to put into your calculator as well. Okay, so here's what you do. You put the number in first. Everybody put in 676 into your calculator. And now what you're going to see is because squaring and square roots are the opposite of one another, right above the X squared button, here's the square root button. It's directly above it. Oh, they're the opposite. So if you see something on this calculator in yellow, you have to push the shift button first, and then you'll push X squared. So you've got 676, you push shift, and then you push X squared. So you're pushing them one at a time. 676, push shift and then let go, and then push X squared and let go. You'll get 26. So push them one at a time. Yep, perfect. Good. Everybody get 26? Yay! So your last side right here, AC, is 26. Hey, what does that mean this leg over here is? Oh, it froze on me. Sorry, guys. Okay. So if this side's 26 right here, what does that mean? This one has to be on this side. It better be exactly the same thing, 26. Good. Woo! Okay. Give yourself a pat on the back. That was a tough one. Okay, what questions can I answer so far? I know that one was a tricky one. That's as hard as it gets right there, but that's the hardest one. Nothing? Really? Seriously? Okay, then let's do our next one. Number 3. Okay, number 3. Number 3 says K cubed bisects the vertex angle.
Yeah, I'm done.
Solve for x. Okay, so what can I mark in this picture? What's something that you see we can mark? Chelsea?
You can mark the,
Sorry. Good.
You can mark the 3x plus 4 on the other side.
Okay, very good. So the angle K that's on the left, this one right here on the left side, is 3x plus 4, which means on the right side, because it's isosceles triangle, it better be exactly the same thing. So this angle right here is also 3x plus 4. Good. What else can I mark in my picture?
On the left.
The 2 legs, which are KB and KG. So this side and this side. These are my legs. Good. What else can I mark? Ah, very nice. These 2 angles better be exactly the same as well. They're my base angles. So this time what I'm going to do is I'm going to put 2 arc marks to show that they're different. But yes, this one on the left is also 4x plus 9. And there's one more very important thing I should mark in this picture. 90 degrees, good, on the other side. Fantastic. Okay, so now you've got 2 smaller triangles that are exactly the same. So let's focus on just one of the triangles. It does not matter which one we focus on. I'm just going to look at this left one here just so that I can get my bearings here. Okay, so I'm going to ignore this one on the left. Now, you're trying to solve for x. We're talking about angle measures on all of these. What do you know about the angles in a triangle? They all add up to 180. So how could I write an equation here that says if I add up all my angles, I get 180? Woo, perfect, good. So essentially all you're doing is a very long algebra problem. You're saying, here's my first piece, 4x plus 9, plus my second angle is 3x plus 4, plus my last angle is, don't forget about that, 90, and it's equal to 180. And then guess what this is, my dears? It's your fave. It's algebra. I know you guys love it so much. What should I do first? Add all your x's. Yep, combine those like terms. So I've got a 4x and a positive 3x, and that's it. So what's a 4x and a 3x? 7x's. Good. What else can I put together? What's left? Yep, 90 and 4 and 9. And if you add those all together, what do you get? Close. 103. All good. Equals 180. Okay, next step. Good. Subtract the 103 on both sides. We get 7x equals 77. And then our last step is divide by 7. What do you get for your x value?
11.
X equals 11. Fantastic. So look, once you mark everything in the picture, it becomes a lot easier to try to solve the problem. And then as we go to solve problems, we look at just one of the smaller triangles instead of trying to look at the whole big triangle, because otherwise we'd get really confused. Okay. Questions there so far? How we feeling? Thumbs up, thumbs down? Feeling okay for that one? That one was better than the last one, right? The one before was the tough one. All right, we're so close. We're almost done. What we're going to do for 4, 5, and 6, because we're kind of running out of time, we're just going to set up the equations. We're not going to do the algebra for the next ones, okay? Because the ones that are left are all algebra problems, and I'm going to kind of skip that just to be sure that we get through just the setups of the equations. Okay. Number 4. What I want you to do right now is mark everything in this picture that you know is congruent. Yes. Mark everything in this picture that you know. So I should see you marking the legs. I should see you marking some angles that are the same.
We'll go back to
Number 3. All right, so for this picture, you got your legs marked. I put in my 90 degrees. And then the other thing I did was I marked my top 2 angles have to be the same with 1 arc mark. And my bottom 2 angles, B and G, have to be the same with 2 arc marks. Now this time the question's a little bit different, right? The setup is a little different than the last setup. And I'm trying to find X. Now, what do you notice about these 2 equations? What do you notice about their locations? B and G are what? What do you mean? Okay, the equations for the 2 of them are different. What do you know about angle B and angle G, though? They're congruent. They're exactly the same because they're in the same location, right? If I were to flip this over to the other side, they're in the same spot. So if these 2 angles are the same, how do I write an equation to say that they're the same? Perfect. I'm just going to set the 2 equations equal to each other because they are the same. So angle B, I'm going to set it equal to angle G because they are exactly the same. 10x minus 7 equals 4x minus 1. Good. I'm going to go like this. Dot, dot, dot. Because I'm going to, like I said, I'm going to skip the algebra for the moment. But you end up getting x equals 1. Okay, so setting up the equation is kind of half that battle there. But because those 2 are the same, I just put an equal sign between the 2. Okay, questions so far? Feeling okay? So when 2 things are congruent, we just put an equal sign right between them. All right, number 5 and 6 are similar to each other. And like I said, we're just going to set up the equation. But for number 5 and 6, it says perpendicular bisectors bisect a segment to create 2 congruent segments. You can have a perpendicular bisector in a triangle that is not isosceles. So for example, this picture here that I'm showing you, right? I've got a perpendicular bisector. I have something that's cutting the triangle in half and creating 90 degrees on both sides. That's the definition of perpendicular. It's making 90 degrees. Now, what do you know about the 2 sides that are left in this picture? What do you know about these 2 equations here? Where are they located? On the outside, good. And what do you know about these 2 sides in this picture? That they're the same. They are congruent. So I'm going to put some tick marks to show that they're the same. And why am I putting 2 tick marks and not 1 tick mark? Yeah, good. I've already used up the 1 at the bottom. Now I've got 2. So if these 2 are the same, what should I do with the equations? Perfect. Because they are congruent, I know that RQ is equal to RS. They're the same length. So because of that, I just take the equations and set them equal. Set them equal. Again, I'm going to go, so I'm going to skip the algebra. And you'll get your final answer is x equals 9 if you did the algebra. Okay, so isosceles are pretty easy because if they're the same, you just set them equal. And then number 6, last one, same idea. An angle bisector bisects an angle. So it cuts an angle in half. So in my picture here, I have 2 angles that have 90-degree angles over here. I've got these 2 side lengths are the same. And then I've got these 2 angles at the top. What do you know about the 2 angles at the top? They're congruent. So these 2 are, again, the same. So how do I write an equation that says these 2 are the same? What should I do? Perfect. Yep, just set the 2 of them equal. And again, I'm not going to do the math, but you get 7. So the idea is if they are in the same location, if they are congruent, we just set the 2 equations equal to each other. All right, you guys did a fantastic job today. Hold on to that. We're going to do the backside, the practice tomorrow. If you really want to try the backside at home tonight, you can, but you do not have to. We're going to do it tomorrow in class. Your only homework really is if you did not finish that IXL from Friday or the survey, or the survey from Friday, then you do have to finish those 2. But if you've already done those, then you do not have any homework for tonight.